Today we will discuss the spectroscopy. Spectroscopy means the interaction between matter and electromagnetic radiations. We know that organic compounds can be synthesized in laboratory, number one, or industry, or may be extracted from natural sources. Organic compounds can be obtained from laboratory and natural sources. We need to characterize them. The sequence of characterization is as follows. Number one, detection of elements. Detection of elements means how many elements are there in an organic compound. Elements present in compound are detected by usual analytical method. Number two, molecular mass and molecular formula detection. Molecular mass and molecular formula detection. And number three is the detection of functional group. Molecular mass and molecular formula detection means then we find out the molecular mass and molecular formula of the compound. Number three is the detection of functional group. Means determination of functional groups in a compound by usual chemical tests is done after that. Number four is the melting point, boiling point, and preparation of derivatives. Melting point, boiling point, and formation of derivatives are carried out to arrive the structure of compound. Now we want to consider the spectroscopy methods for the determination of structure in a more clean and convenient manner. Spectroscopy may be defined as the interaction between matter and electromagnetic radiation. Matter, anything which have mass and occupy space, and electromagnetic radiation, you can say it light waves. Visible light is a form of energy. Okay. Spectroscopic methods give almost foolproof insight into detailed structure and stereochemistry of compound. These methods of analysis include ultraviolet and visible, infrared, nuclear magnetic resonance, and mass spectroscopies. In this chapter, we shall restrict ourselves to the first spectroscopy. Now we discuss the electromagnetic radiations. Electromagnetic radiation. Light is supposed to travel in waves. Light is supposed to travel in waves. Visible light is a form of energy. Visible light is a form of energy. It can be explained by two complementary theories, the corpuscular theory and wave theory. Number one theory is the corpuscular theory. And number 2 is the wave theory. All the properties of light can be explained by considering both the theories. According to the wave theory, light travels in the form of waves. It is believed that radiant energy is emitted by fluctuation of electric charge and magnetic field. It is believed that radiant energy is emitted by fluctuation of electric charge and magnetic field. Some of important characteristics of electromagnetic radiations are these. Number 1, electromagnetic radiations are caused by the oscillation of electric charge and magnetic field. Electromagnetic radiations are produced by the oscillation of electric charge and magnetic field. The electric and magnetic components are mutually perpendicular to each other and coplanar, like these are the perpendicular 90-degree is the angle, direction of electromagnetic waves. Electromagnetic radiation consists of oscillating electric and magnetic fields that are perpendicular to each other, perpendicular to the direction of propagation of wave. Now we discuss the second point. We discuss here that matter and energy interaction, matter and electromagnetic radiations. Interaction between matter and electromagnetic radiation is called spectroscopy. Organic compounds are manufactured in laboratory in natural and are obtained from natural sources. And the sequence of characterization to organic compounds is given by detection of elements, molecular mass and molecular formula, detection of functional group, melting point, boiling point and propagation of derivatives. Electromagnetic radiations, there are two theories which explain the electromagnetic radiation. Light travels in the form of waves, corpuscular theory and wave theory. According to wave theory, radiant energy is emitted by fluctuation of electric charge and magnetic field. Okay, and then this is the magnetic field and electric field mutually perpendicular to the direction of propagation of waves from where waves are created. Now the second point is these are characterized by their wavelength, frequency or wave number. These are characterized by their wavelength, frequencies are wave number. Electromagnetic radiation. For example, here is a wave we discuss. This is a wave. Okay, here is a low frequency. It is a long wavelength. This is wavelength. Wavelength is represented by lambda. Long wavelength. This is wavelength. Lambda. And here is the short wavelength. Short lambda. Oh, sorry. This is also long wavelength. Long wavelength. Short wavelength discuss later. And this is the amplitude from this distance to this distance. This is amplitude. Amplitude. Like from this to this, it is amplitude. Amplitude. This is here is low frequency. Now it is also a wave which is very short lambda. So from there to there, it is also a wavelength lambda, which have this short wavelength. The amplitude, wavelength, and frequency of wave are illustrated here. The frequency of wave is the number of complete waves passing a fixed point at a given time. Now discuss the number 3 point. The energy carried by electromagnetic radiation is directly proportional to its frequency. Frequency is represented by V. The emission or absorption of radiation is quantized, mean packets of energy, and each quantum of radiation is called photon. Photon means packets of energy. This concept is given by Planck's quantum theory. E is equal to hv. This is very important concept. Planck's quantum theory. E is equal to hv. E is the energy of photon. Energy of photon. And V is the frequency of photon. V is equal to C over lambda. E is equal to hc over lambda. Greater the wavelength, smaller the energy possessed by a photon. Greater the wavelength and energy are the inversely proportional to each other. Greater the wavelength, smaller the energy. Smaller the wavelength, greater the energy. This is the concept. Since this is the wave number is equal to 1 over lambda, this is wave number. E is equal to hc wave number. This is the final equation. This is the wave number of photon. Greater the wave number, greater the energy associated with the photon. E directly proportional to wave number and inversely proportional to wave. Okay. In this we discuss the Planck's quantum theory. Now number 4 point. Number 4 point is the all types of radiation travel with same velocity and no medium is required for their propagation. All types of radiation travel with the same velocity. Travel. Same traveling velocity. velocity. Same traveling velocity, all waves have same traveling velocity. And no medium is required. No medium is required for their propagation. Okay, and now number 5 point. Number 5 point, when visible light is passed through prism, it splits up into 7 colors. When visible light is passed through a prism, then it splits 7 colors. 1, 2, 3, 4, 5, 6, 7. Each color corresponds to definite wavelength. Each color have definite wavelength. This phenomena is called dispersion. Dispersion. Now we discuss the electromagnetic spectrum. Electromagnetic spectrum. Very important. When sunlight is passed through a glass prism, then various regions of spectrum are observed. When sunlight is passed through glass prism, this is a glass prism and this is a sunlight is passed through the prism, then various spectrums are observed. These regions are spread on the photographic plate due to their different wavelengths, frequencies and wave number. The electromagnetic waves wave of high frequency are short wavelength, like cosmic rays and gamma rays, are bent to maximum extent. On the other extreme, microwave and radio waves region are observed. Somewhere in the middle we observe UV, ultraviolet and visible and infrared regions. All types of electromagnetic radiations are arranged in order of their increasing or decreasing wavelength. All types of electromagnetic radiations are arranged in order of their increasing or decreasing frequencies, increasing wavelength or decreasing frequencies. This is known as complete electromagnetic spectrum. This is the whole definition of the electromagnetic spectrum. All type of electromagnetic radiations are arranged in order of their increasing wavelength or decreasing frequencies is called electromagnetic spectrum. So this is the definition of electromagnetic spectrum. Complete electromagnetic spectrum. The visible part represents only a small portion of electromagnetic spectrum. Visible part represents only small portion of electromagnetic spectrum. If we arrange all types of electromagnetic radiations in order of their increasing wavelength, then the portion above visible region is called infrared, while that below it is called ultraviolet region. Infrared radiations have longer wavelength. IR have long wavelength. Longer wavelength and thus less energetic and less energetic. Cosmic rays high energy. Cosmic rays has high energy. Infrared radiations have longer wavelength, are thus less energetic, and cosmic rays have high energy, and radio waves are least energetic. Least energetic radio waves are also less energetic. Radio waves less energetic. Okay. Although all types of radiation travel in as wave with the same velocity, yet they differ from one another in wavelength, in frequency and wave number. Wavelength, frequency and wave number. They travel with same velocity but different wave number extra. Now we discuss the electromagnetic spectrum. This is an arrow with increasing energy, okay, this is the electromagnetic spectrum in which visible part is elaborated. Number one is the cosmic rays, cosmic and lambda rays, cosmic and lambda rays. Number two is the X-rays, X-rays. This is from 0.1 nanometer. After X-ray, UV, vacuum ultraviolet, 200 nanometer. This is 0.1 nanometer. X-ray started from 0.1 nanometer. UV, this is the vacuum, UV vacuum ultraviolet. This is a UV near UV, and here is a 400 nanometer. After this 400 nanometer visible 400 to 800 nanometer visible, in which we are living. NIR, near infrared, 800 to near IR, near IR 2 VM, IR, these are original IR, 2 VM to 50 VM. And then microwave radio, and next is the radio. So this is the figure, and here is the 10 to raise power 19 hertz frequency, visible 10 to 15 hertz frequency, and microwave 10 to 13 hertz. Here is the increasing energy, right? Increasing energy. So this is the various colors electromagnetic spectrum. This is The electromagnetic spectrum, you can take the screenshot here. This is the definition. Now we'll discuss the names and wavelengths range of colors of visible region. In next page, you can take screenshot of this page. This is the electromagnetic spectrum we have discussed. Now the next is the VBGGYYOR. VBGGYYOR. Violet, blue, green blue, green blue, green, and yellow green. Next is the yellow, orange, or red. Violet wavelength, these are the color, this is the wavelength. Color, wavelength. Violet wavelength is 400 nanometer to 435 nanometer. Blue is 435 to 480 nanometer. Green blue is the 480 to 490 nanometer. This is the lambda, and green wavelength is the 500 to 550 nanometer, and yellow green is the 560 to 580 nanometer. Yellow is the 580 to 595. Orange is the 595 to 650. Red wavelength is the 650 to 800. So red has the more lowest wavelength. Parameters related to spectrum of light. Now we discuss the parameters. You can take the screenshot of this. We discuss the violet have 400 to 435 nanometer wavelength, and blue is the 435 to 480 nanometer. Remember it, these are very important. Green, blue have 480 to 490 nanometer, and nanometer is the for all. These are the wavelength, these are the colors. Colors, wavelength, colors, wavelength, wavelength, colors. So this is the complete spectrum related to parameters. This is the original. You can take screenshot of this. And now we'll discuss the parameters related to spectrum of light. Parameters related to spectrum of light. Spectrum of light. First is the wavelength. This is one of parameters of wave. This is one of the parameter of wave. It is the distance between two successive crusts or troughs. Definition is the distance. It is the distance between two successive crusts or troughs of the wave. Wavelength is the distance between two successive crusts or trough. It is denoted by Greek letter lambda representation. The maximum displacement of wave is called amplitude. Maximum displacement of a wave is called amplitude. Amplitude, what is amplitude? Amplitude. Amplitude is the maximum displacement of wave, of any wave, is called amplitude. So amplitude definition we have covered. You can remember these colors also. And now next we discuss the things. An amplitude is denoted by this. This is amplitude, and this is lambda. Lambda means wave. Different regions of electromagnetic spectrum possesses different wavelengths. Different units for expressing wavelength have been used in past. National Bureau of Standards 1963 has recommended nanometer as unit of wavelength. NBS, National Bureau of Standards 1963 has recommended nanometer as the unit of wavelength. Nanometer is the unit of wavelength. 1 nanometer is equal to 10 to the raised power minus 9 meter. Sometimes one comes across other units of wavelength. Okay. Visible light constitutes wave ranging from 400 nanometer to 800 nanometer. Visible light we have discussed first. Visible light 400 nanometer to 800 nanometer. Different colors of light have different values. Different colors of light have different values. Values of their wavelengths. Human eye is sensitive only to this small visible range and cannot detect ultraviolet light, which is less than 400 nanometer, and infrared radiation, which is more than 800 nanometer. Ultraviolet light can be detected by photoelectric cell, and infrared light can be detected photographically. Ultraviolet light is detected by photoelectric cell, and IR light detected by photographically. Ultraviolet light is detected by photoelectric cell, and IR detected by photographically. In some techniques like ultraviolet and visible spectroscopy, the common unit is wavelength. Okay. These are the wavelengths. These are the parameters related to wavelength. Wavelength we discuss. This is a very important article. You can see it and take the screenshot. This is very important. Consider all. So if you want to, I give you make a figure. This is the wavelength. Okay, this is the amplitude from this to this. This is amplitude. Amplitude is denoted by this. This is amplitude, and this is a crust. These are two crusts. Okay, and these are trough. Distance between two exactive crusts. These are crusts and these are trough. Distance between two troughs is called wave, is called lambda. Distance between two crusts or trough is called lambda. Now we discuss the wave number. Wave number. What is the wave number? It is a reciprocal of wavelength. Reciprocal of wavelength. And it is expressed in per centimeter or per meter or per centimeter. In other words, it is defined as total number of waves which can pass through a space of 1 centimeter or 1 meter. It is expressed in this as if the wavelength of light radiation is known, the corresponding wave number can be calculated. For example, if the wavelength of radiation is 10 to raise power minus 5, then correspondingly we can find its wave number. Like this is lambda is equal to 10 to raise power minus 15 centimeter. This is the wave length. Now we find the wave number. Wave number is denoted by this and its formula is this. So we put the values of wave 10 to raise power minus 5 or 15, right, 5. So next it become 10 to raise power minus plus 5 centi per meter, and it can also be written in per meters 7 per meter, because 1 meter is equal to 100 centimeter. Okay, so these are the wave number. Now third parameter is the frequency. Frequency is defined as the number of waves which can pass through a point in 1 second. Definition is the number of waves which can pass through a point in 1 second is called frequency. It is expressed as V in cycle per second or hertz, where 1 hertz is equal to 1 cycle per second. 1 hertz is equal to 1 cycle per second. Frequency is inversely proportional to wavelength. Frequency is inversely proportional to wavelength. Greater the wavelength, smaller is the frequency. 1 Hz is equal to 1 cycle per second. 1 megacycle is equal to 10 to the power 6 Hz. 1 megacycle is equal to 10 to the power 6 Hz. Frequency is V is equal to C over lambda. C is the velocity of electromagnetic radiation. C is the velocity of electromagnetic radiation. Velocity of electromagnetic radiation. Okay, this is the things related to frequency. Now see some numericals. If you want, you can numericals by using these formulas. These all formulas, like this formula, wave number is equal to 1 over lambda. Lambda is the wavelength, and you can define, you can differentiate between wave number and wavelength extra. This is the all related about the different things: electromagnetic spectrums, electromagnetic radiations, parameters related to electromagnetic radiations, and detection of elements, molecular mass and molecular form extra. X-rays can pass through glass and muscle tissues. I want to give you the important information that the X-rays can pass through glass and muscle tissues. Radio waves can pass through air. Visible, ultraviolet and infrared radiations can be bent by reflection or diffraction in a prism, and so on. This all depends upon the amount of energy they possess. Okay, now we are discussing very important topics. Spectroscopy is the branch of science which deals with the process of interaction of light with matter. Light and matter interaction called spectroscopy. Light and matter interaction called spectroscopy. If some light radiation is passed through a sample of an organic compound, some light is passed, then some of wavelengths are absorbed while other belonging to this, for example 3, 4, 5, 4 are passed through organic compound and only 2 are emitted. Then the sum of wavelengths are absorbed and other belonging to that light source remain unaffected. These 2 lines are unaffected. A molecule can only absorb radiation of certain frequency. The reason is that there exists within a molecule an energy transition of magnitude, that I which is equal to hv. Actually, what happens is that when 100 to 800 nanometer ultraviolet or visible range, light radiations are passed through an organic compound, then electrons of component atoms are excited. Electrons of component atoms are excited. In addition, the vibrational, rotational and electronic energies of the molecules as a whole are quantized. Thus, any wavelength of light that a particular molecule will absorb will be due to change in the electronic vibration are rotational energy levels permissible for its atoms. The wavelengths absorbed are measured with the help of spectrometer. If we plot the changes in absorption against wavelength, we get certain absorption bands. We get certain absorption bands. These bands are highly characteristic of a compound. This technique provides an excellent tool to know the molecular structure of an unknown substance. Now we'll discuss the regions of electromagnetic spectrum. First is the visible and ultraviolet radiations. Visible and ultraviolet radiations. They cover the wavelength range from 100 to 800 nanometer. These are the regions of electromagnetic spectrum. While 400 to 800 nanometer is the visible region. The absorption of radiation in this region is due to excitation of pi electrons in a conjugated or an unconjugated system. In case of conjugated system, the separation between the ground state and excited energy level will be less. In case of conjugated system, the separation between ground and excited energy level, in case of conjugated system, the excited and ground energy level will be less. Separation will be less. Hence, absorption occurs at longer wavelength or at lower frequency. Longer wavelength or low frequency. Longer wavelength or low frequency. Now, second is the IR radiations. Infrared radiations. The cover the wavelength range from 800 nanometer to 2500 nanometer or 0.8 mu to 2.5 mu and constitute near infrared region. The region from 15 to 25 mu is called fair infrared region. 15 to 25 mu is the fair infrared, fair IR region. This is the exact IR region. The most useful region for infrared spectroscopy is 2.5 to 15 micron, means 25 nanometer to 5000 nanometer. Very, very useful. These radiations of near, middle and fair IR regions are of higher wavelength than UV and visible and are hence less energetic. The absorption of IR radiation by the organic compound causes molecular vibrations. The changes in the vibrational levels are accompanied by the changes in the rotational levels. Thus, the certain bands appear which characteristically absorb for the stretching vibrations and are very helpful in structure elucidation. Elucidation means structure, a clear structure. Absorption at higher wavelength in infrared region called fingerprint region. What is fingerprint region? In IR, fingerprint region. The absorption at higher wavelength in IR. The absorption of at higher wavelength in IR is called fingerprint region, are most characteristic of compound. It helps in distinguishing one compound from other. It is used to separate one compound from other. Nuclear magnetic resonance spectroscopy. Number 3 is the NMR spectroscopy. It provides a complete insight into the environment and arrangement of atoms within a molecule. For this technique, radiations of longest wavelength range like radio waves are useful. A sample under investigation is placed in a strong magnetic field. Then it is irradiated with radio waves depending upon the strength of magnetic field. Employed radiations of definite wavelength or frequency will be absorbed. The photon of this frequency will bring the nuclear magnets into specific orientations with respect to applied magnetic field. The photons of this frequency will bring the nuclear magnets into specific orientations with respect to applied magnetic field. The spin of nucleons charges from alpha to beta. Alpha is the lower energy and beta of higher energy, but to different environmental effects, different magnetic nuclei, say option N15, C13, F19, P31 atoms extra will feel the applied magnetic field differently. Hence, absorption at different field strength will correspond to different sets of photons. Protons are magnetic nuclei from the ultraviolet radiations, and NMR, nuclear magnetic resonance spectra of an unknown compound. It is possible to determine the structure. Now we discuss the summary table of these things. Radiations. First we write the radiations. Radiation absorbed, radiations absorbed. Number one is the ultraviolet UV. UV which have wavelength 100 to 400 nanometer and visible which is 400 to 800 nanometer. Effects on molecule. Its effects on molecule of substance and information obtained. It changes in electronic energy levels. Ultraviolet and visible changes in electronic energy level. Electronic energy level within the molecule conjugated unsaturation conjugation with non-bonding electrons. Extent of pi electron system. Ultraviolet and visible radiations changes in electronic energy levels. Electronic energy levels within the molecules conjugated unsaturation conjugation with non-bonding electrons. Extent of pi electrons. Now we discuss the second thing, which is the IR, infrared. 667 to 4000 centi per meter, 2.5 micron to mu to 515 mu. It changes in vibrational and rotational movements of molecule. Changes vibrational and rotational movements of molecule detection of almost all functional groups. All functional groups which have the specific vibrational frequency. Such as C double bond O and OH and NH2 and C triple bond C extra. So this is the infrared. Now we discuss the third, radio frequency. Radio frequency. Frequency is the 60 to 300 megahertz. Radio frequency is the 60 to 300 megahertz. Nuclear magnetic resonance. Nuclear magnetic resonance induces changes in magnetic properties of certain atomic nuclei, certain nuclei, notably that of hydrogen. So this is the effect of radiations on molecule of substance and information obtained. This all. So you can take the screenshot of this and remember it at last. So now, if you like our video, then subscribe and like and press the bell icon and share it with your friends. And if you need tutor online for any class, for any subject, you can contact us. We have a lot of tutors. Thank you very much.